What if I told you that scientists just built a time machine? Not a time machine that can take you or me back to see dinosaurs, but something even more incredible. Imagine a machine that can travel back to the very first moments after the Big Bang, to a time before stars, before galaxies, even before light could freely travel through space. This isn't science fiction, it's happening right now in a laboratory. A team of brilliant researchers has managed to recreate the very first molecule that ever formed in our universe. This is a huge deal. It's like finding the first ever word written in the epic story of our cosmos. This single achievement is unlocking secrets that have been hidden for over 13 billion years, and it might just change everything we thought we knew about where it all began. Think about the universe right after the Big Bang. It wasn't the beautiful, star-filled expanse we see today. It was a hot, dense, soupy fog of tiny particles. It was a chaotic, sizzling environment where nothing complex could exist for long. As the universe expanded and cooled down, these fundamental particles started to come together. Protons, neutrons, and electrons began to form the first atoms, mostly hydrogen and helium. But for the universe to evolve into the amazing place it is today, with stars, planets, and life, those atoms had to take the next crucial step. They had to join together to form molecules. Understanding that first molecular handshake is key to understanding our own origins, and that's precisely what this new research has allowed us to witness for the very first time. This discovery feels like finding a lost chapter from the beginning of a book. For decades, scientists had theories about what this first molecule was and how it behaved, but they couldn't be sure. It was like guessing the plot of a movie based only on the poster. Now, by creating these molecules here on Earth, they can study them directly. They can test their properties, see how they react, and compare that data to what our telescopes observe from the farthest reaches of space and time. It's a monumental step forward that connects the tiniest, most fundamental physics in a lab to the grandest, most epic story of the cosmos. This isn't just a small update to our textbooks. It's a whole new way of looking at the universe's baby pictures. What makes this so incredibly exciting is the sheer audacity of it all. We are tiny beings on a small planet, orbiting an average star in one of billions of galaxies. Yet we have the curiosity and the ingenuity to reach back across 13.8 billion years and recreate the conditions of the universe's birth. It's a testament to the power of science and the human desire to understand our place in the cosmos. This breakthrough doesn't just answer old questions, it opens up a whole new set of mysteries to explore. It's a reminder that the universe is full of wonders, and we are just getting started on our incredible journey to uncover them. Get ready, because the story of the universe just got a thrilling new update. So what was this amazing first molecule? It's called helium hydride, and its chemical symbol is HeH+. It might not sound as famous as water or oxygen, but it is arguably the most important molecule in the history of the cosmos. Think of it as the ultimate ancestor of every other molecule that has ever existed. After the Big Bang, the universe was mostly made of hydrogen and helium atoms. For anything more complex to form, these first atoms needed a way to connect. Helium was a noble gas, meaning it didn't like to react with anything. Hydrogen was eager to bond, but it needed a partner. Under the extreme conditions of the early universe, a helium atom and a proton, a hydrogen nucleus, were forced together to create helium hydride. So how did scientists manage to cook up a piece of the early universe in a lab? It sounds impossible, but it was achieved through a brilliant combination of clever physics and cutting-edge technology. The researchers couldn't exactly recreate the Big Bang, of course. Instead, they focused on recreating the specific conditions that would have allowed helium hydride to form about 100,000 years after the universe began. They needed to bring helium atoms and protons together at just the right energies and in a controlled environment where they could observe what happened. It's like being a cosmic chef trying to follow a 13.8 billion-year-old recipe with very precise instructions. To do this, they used a special piece of equipment called an ion trap. You can think of an ion trap as a tiny invisible cage made of electric fields. First, the scientists cooled a cloud of helium atoms down to extremely low temperatures, just a few degrees above absolute zero. This slows the atoms down, making them easier to control. Then, they used powerful lasers and electric fields to hold these super cold helium atoms suspended in the middle of a vacuum chamber. This step is crucial because it isolates the atoms from the outside world, ensuring that nothing else can interfere with the experiment. It creates a pristine, miniature version of the early universe's environment, Once the helium atoms were trapped and cooled, the next step was to introduce the protons. Protons are just hydrogen atoms that have lost their electron. The scientists created a beam of protons and carefully guided it into the ion trap, sending it right through the cloud of helium atoms. They had to precisely control the speed, or energy, of these protons. If the protons were moving too fast, they would just zip past the helium atoms without reacting. If they were moving too slow, they wouldn't have enough energy to form a chemical bond. They had to find the Goldilocks energy level that matched the conditions of the early universe. By carefully tuning the energy of the proton beam, the scientists were able to trigger the reaction they were looking for. A proton would collide with a helium atom and stick to it, forming the elusive helium hydride molecule, HeH+. The team could then use sensitive detectors to confirm that the new molecule had been created. It was an incredibly delicate and painstaking process, requiring immense precision and patience. But by successfully pulling it off, these scientists didn't just prove a theory. They effectively opened a small window into the universe's chemical nursery, allowing us to watch the very first step of cosmic chemistry as it happened. When the scientists finally succeeded in creating and studying helium hydride in their lab, they were in for a major surprise. Their models of the early universe had predicted how quickly helium hydride should form under certain conditions. For years, these predictions were the foundation of our understanding of early cosmic chemistry. Everyone expected the experimental results to neatly match these long-held theories. But that's not what happened. The results from the laboratory were different, and this is where the story gets really interesting. Science is at its most exciting not when it confirms what we already know, but when it reveals something completely unexpected that challenges our assumptions. This single laboratory result has the potential to rewrite the first chapter of the universe's history. If helium hydride formed at a different rate than we thought, it means the timeline for the birth of the first stars needs to be adjusted. This adjustment could solve some long-standing cosmic mysteries. This discovery doesn't just belong to scientists. It's a piece of our shared universal heritage. Moreover, this kind of fundamental research is what drives technological innovation. Finally, this discovery is a source of inspiration and wonder. This incredible breakthrough is not the end of the story. It's the beginning of a new, exciting chapter in our cosmic quest. With their experimental setup now proven, scientists can begin exploring other key chemical reactions that were crucial in the early universe. This will allow them to build a much more detailed and accurate chemical map of the universe's first few 100,000 years. I'd love to know what you think. Does this discovery change how you see the universe? Thank you so much for joining me on this incredible journey back to the dawn of time. The universe is a vast and amazing place, and it's discoveries like this that remind us how much there is still to learn. The adventure of science is a collaborative one, and your curiosity is a vital part of it. What do you find most exciting about this discovery? Do you think it will lead to even bigger revelations about the universe? Let me know your thoughts in the comments below. And if you love exploring the wonders of science and the cosmos, don't forget to like, comment, and subscribe for more amazing stories. Thanks for watching.